Good day, everyone. Welcome back to my training series entitled Understanding EMV. Okay, we are currently in the EMV acquiring section, and in this video, which is the 14th video in the training series, we'll be working through the second step of the EMV transaction. Okay. So let's get straight into it. So in the previous video, we covered technology selection, and where we are right now is we've got Bob wanting to buy a pair of socks for his wife Sally. He's at the comic book store. He's standing at the till. Uh, the teller asks, how would you like to pay for your purchase, sir? Bob says, he whips out his card, says, I'd like to pay with my card. The terminal is EMV compliant. The card is a chip card, so the teller asks Bob, please insert your card into the device, which Bob does. The terminal powers up the card. It's obviously we've completed technology selection. We know that in this transaction we're going to be doing an EMV or a chip transaction. Okay, so step 2, which is the focus of this video, is all around application selection. Okay, so let's get straight into it. Okay, so at this point in time in the transaction, we've got a terminal that's powered up or supplied power to the chip. So we've got a card that's a microcomputer. It's capable of its own risk management, its own processing. It can work, like a computer that we're used to. And so what needs to happen is, none of the microchip is powered up. The terminal is able to have a conversation with it, right? So the very first thing that the terminal would like to do is to identify, what sort of payment applications are available on the card that the terminal itself can actually process. Okay, and to make these available to the customer, to Bob, so that they can choose the card and the account that they would like to use for this transaction. So the selection of possible cards is firstly shortlisted on the terminal in the form of a candidate list, and the candidate list is displayed on the terminal screen. Right. So what we want is to get to a point where we can show the user or the cardholder a list of a potential card and account that he could use for this specific transaction. Okay, and so the purpose of this video is to actually look a bit more in depth into this process of creating the candidate list and offering it to the customer. We just have to be aware that there are many different types of cards out there, right? So you've got just single app cards. It's a card with a single application. You've got multi-app cards, a card with multiple applications, and then you've got multi-account to access cards. So it could be a card with a single application, but potentially is linked to multiple backend accounts. And I think before we proceed with the application selection, let's try to understand what the differences are between a single app, a multi-app, and an access card. Okay, so let's look at the single application card. So we've got a credit card. It's got a PAN of 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's one physical plastic, right? You guys agree? One physical card, one physical piece of plastic. It's got a chip. So it's got a chip, and on the chip we have a virtual card, right? An application that carries a pen, and let's say in our case it's 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So this virtual card has a pen of 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and the pen of this virtual card is also printed on the face of the physical card. All right, fairly straightforward. I think we're all used to this sort of scenario. Okay, and usually this is associated to a single account on a backend system. So this card number will directly result in the debit of a single specific account on the backend system. The next scenario we need to look at is a multiple application card or a multi-app card, as we refer to it. So in this case, it's still one physical card and one physical piece of plastic that sits in your purse or in your wallet. However, within the chip, what you'll find is that there are multiple virtual cards, multiple virtual cards or applications. Uh, and generally, of those multiple virtual cards, one of them will be designated as the primary card or the primary application. And usually the pen of this primary application or primary virtual card is the pen that gets written to the face of the physical card. Right. So in this case, the primary application, the primary virtual card, has a pen of 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and this lives on the chip itself. But and in this case, it's displayed, it's embossed on the face of this card. Then you've got a second card. Remember, once again, same plastic, but it's a virtual card that resides on the chip. And this one could have a pen of 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Okay, and you won't see this pen on the face of this card, but some issuers will issue a card where they will actually print the second card pen on the back of the card, and that's to allow you to understand what the pen is in the event that you want to use the second card or the second virtual card for online purchases, for e-commerce transactions. Okay, and you could have more than two. I mean, so let's assume that there was a third virtual application on this card, and the pen was 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9. And similar to this, it exists as a virtual application, a virtual card, and this unique pen number may also be printed on the back of the card somewhere, also for the purposes of e-commerce. It's not always printed. Some issuers don't print the other virtual application pen numbers. They only print the primary ones. So it depends on which issue and what their rules are around this. It's always a good idea to print them all, just to give the card all the options in terms of which card they'd like to use for e-commerce transactions. Okay, and each virtual card or each application may be associated to a different account on a backend system. So let's look at it in a bit more detail, right? I've got the physical plastic, and on the face of the plastic, I've got a pen of 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8 embossed on it. And I've got a host system, which basically is the issuing system that you issue the card. It holds the accounts that you issue the cards against. So let's assume that that the pen that's displayed here, okay, relates to a credit account, 00100810. Right. Then we spoke about that second virtual application with a pen of 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, and that could relate to a separate account, a check account 426607. Excuse me. And this also resides on the host system as a separate account from the original credit account. And then you'd have a third one, right? And the same principle, it relates to a different, right? And remember, I mean, if you look at the example I'm using here, you've got the first card, the credit card. The second card, virtual card, is a check card, and the third card, virtual card, is a debit card. It transacts against a savings account. All right. So the important thing to note is that during a transaction, depending on which of these card numbers you choose, that's the pen that will appear on the ISO 8583 message. So, if you stick the card in, and even though your physical card has this pen, if you've chosen to complete the transaction with a check account, the ISO 8583 message being transmitted upstream and downstream will actually have this pen number because that's the one you selected, and the debit will then happen not off the account linked to this pen here. It'll be debited off the account linked to the pen that you chose. Okay, I hope that makes sense. Okay, the third scenario is a multiple account link card or an access card. Right, not very common, but you do see them out in the market. And what you are basically seeing is similar to the others. One physical card, one virtual card. So like for like, so one application or one virtual card, the pen of this virtual card is printed on the face. Okay. However, this physical and virtual card may be associated to multiple accounts in the backend system. Okay. So just to clarify, let's look at a picture of it. So, similar to the previous example, I've got a physical card, and here's the pen, right? And we mentioned in this case, it's a single application only, right? Uh, but what you'll find is that if you look at the whole system, this single card number could have access to a credit card, a credit account, a check account, or savings account. Right? So on the multiple application card uh, that you spoke about in the previous example, we had 3 different virtual cards, each one relating one-to-one to a different account. In an access card scenario like this, that is a mistake. It should actually be access card is, so please excuse me for that. In this case, where you've got a single virtual card, but it could link. You could use it to transact against, one of 3 accounts. You will not be able to transact against any account from a POS device. Just to be clear, generally, if you're using this card on a POS device, it will default to its default account, which in this case would be the credit the credit account. However, if you put it into an ATM, you'd find that once the ATM reads this card number, it would then find linked account on the back end and allow you to then do withdrawals against any one of these accounts. Okay, so just important to understand that distinction. So for the purpose of this training, let's assume that we are working with scenario 2. So what we are looking at is a multi-app card. So it's one physical card. We've got 3 virtual cards or 3 applications on the card, and each one of these applications speak specifically to a separate account. So virtual card 1 speaks to a credit account, virtual card 2 speaks to a check account, and virtual card 3 speaks to a savings account. Okay. So we need a candidate list so that we can present it to the customer and let them decide, which of the 3 cards they would like to use, right? The credit, check, or savings. The candidate list may only be made up of applications that are mutually supported by both card and terminal. Okay. Now, there are 2 possible ways to identify which AIDs. We know what an AID is. We've talked about it in previous videos. An AID is an application identifier. And there are 2 possible ways to basically figure out mutually supported AIDs: implicit selection and explicit selection. And if you guys recall, I did sort of allude to this in one of the earlier videos, when we were speaking about the parameters that are encoded on the card in one of the EMV issuing videos, and we spoke about the use of a payment systems environment, a PSE, that enables implicit selection. Okay, so let's talk a bit more about that now. Right, so implicit selection requires a PSE, a payment system environment on the card. As I mentioned, we have chatted about it before, so you should know what I'm talking about. So I've got a card, and on my card I've got a primary application, and that's the one where the pen number is printed on the face. But I've also got 2 other virtual cards or 2 other applications that we sort of can't see on the face of the card, but we know it's there, right? This is the multi-app card, and I've got a POS device that is chip capable. Okay, so this is Bob now with his multi-app card. He's stuck into the terminal, and the terminal says, okay, now we need to ask Bob which card he wants to use for the transaction. So the process is simple. The terminal has a look at the PSC and says, okay, on the PSC I've got 3 entries here. A80 is 41010, so this is either MasterCard debit or credit. I've got a 43060, and I've got a 46000, right? So I can't think of what it is offhand. but we'll get to that. The terminal itself supports 4 different AIDs. It supports A31010, which is a Visa credit debit card, A41010, which is a MasterCard credit debit card, A43060, and A1523010, which I'm not sure if it's Amex or Discovery right now. Okay, but the important thing to note is this. What the terminal does is that it compares the PSE on the card to the AID list that's stored on itself, and it looks for matches. Now, in this particular scenario, it's only found 2 matches. So the terminal's got 4 possible options available. The card's got 3 possible options, but of these, only 2 are mutually supported, and the 2 are the 41010 AID and the 43060 AID, right? So it's present on the PSC and it's present here, which means that the candidate list can only contain these 2 matching AIDs. Okay, we should exclude the non-mutually supported entries from the candidate list. Okay, so the candidate list in this case, as we said, will be A80's 41010 and A80's 43060. Okay. Now, in the event where the issuer has opted not to include a PSC on the card when they've issued or personalized it, then this transaction would not have that direct comparison to make, to say, let's find a PSE, let's compare it to my AID list, and let's find the mutually supported applications. And that so implicit is a much faster way of building the candidate list than explicit. And when I say much faster, I mean in computer terms. Obviously, in human terms, it's very noticeable. Okay, but let's assume that Bob's card does not have a PSE, right? So same scenario, we've got the same card, same 3 virtual applications, same terminal. In this case, however, the terminal doesn't have a PSE that you can just sort of have a look at and compare. So what it's got to do is that it's got to check them individually. Okay, and so it says, Mr. Card, I've got an AID A31010. Do you have it? Card says, no, I don't. Terminal remembers, okay, so I must exclude this from the candidate list. It then says, card, do you have application ID A80's 41010? And the card says, yes, I do. So the terminal says, okay, cool, I'm going to add this to the candidate list. Okay, and it does the same for the next one. Do you have it? Yes, it does. Add it to the candidate list. Is this AID present on the card? The card says, no, it's not. So exclude it. And so what you end up with is the same net result, right? We've got a candidate list with 2 entries, except that this was a slower way because the terminal had to run through its list of AIDs and pull the card one by one, to see if the AID is present on the card. Okay. Now, if you are working with EMV, you at some point you generally have to interrogate the logs. When you have specialized tools that allow you to see the conversation between the card and the terminal, and it's very useful. It's very important that we use these tools, when we're doing development or testing or whatever it is in the EMV world. So I mean, what I've got you are examples of a particular tool that I won't mention the name of the tool, the brand, but the sort of logs are the same across regardless of which tool set you're using, right? So what you'll see is that IFD refers to the terminal, right? So the terminal is saying it's issuing a command select file command, right? It's saying I want to select this particular recorder, okay, A8031010. ICC refers to the card, so the card responds back with the value of 68, saying, hey man, file missing. Okay, so you checking to see if I've got this AID and I don't. So file missing. It responds, and so the terminal knows when it gets to 6882, it knows, okay, hang on, this AID is not present on the card. Okay, then the terminal goes to the next one on this list. It says, hey card, do you have 32010? And the card responds, here's the ICC line here, says same 6A82, nope, file missing. So the terminal knows, okay, so let's exclude this AID from the candidate list. The terminal then asks, do you have 41010? And now you'll see that the ICC has responded with data, right? So unlike a 6A82 response file missing, it actually comes back with a string of data here, right? Which is a good sign for us, right? So if you go into the data analysis, so if we look at what the string of data means, let's expand it. Okay, I'm not going to sort of talk you through every single thing yet. I think the important thing is that the ICC has responded, and in the response it says, yes, there, can you see? You've asked me if I've got AID 41010, and I'm coming back and say, yes, I've got 41010. Okay, and it gives a bit of, it gives extra information as well, right? So it will respond and say, associated to this AID, 41010, I've also got a tag called application label with a length of 10, okay, and the value, here's the value, 4D. So application label is tag 50, is it there, and the value is 10 characters, so up to 64, and this is in hex, and if you convert the hex to ASCII text, you actually end up with the application label of MasterCard. Okay, it also has an application priority indicator. We've spoken about this during one of the earlier videos. So it's there, and the value is 01, right? So there's the tag 87 is the application priority indicator. It has a length of 01. It has a value of 01. 01 means it is priority 1. It has the highest priority on the card itself. Okay, and I mean there's other stuff we spoke about PDOLs. So when the card responds back with information, it also slips in a PDOL. Remember, a DOL is a shopping list. Processing options data object list. The data object list is a shopping list. It says, can you please send me back some information around your terminal capabilities, your terminal country code, your terminal type, additional terminal, etc. And at the end of it, the card says, 9,000 successful. So unlike this way, it says, I don't have this AID on me. In this case, I do have it, and I have passed all the information regarding it, and I've even asked for some other information, and the communication around this between us was successful. There was no break in communication. Okay. And obviously that process will continue. So the terminal will run through all of the AID entries on the AID list, and it will either get a file missing response back from the card, or it will get the data that it asked for, right? And obviously where data is available, then that particular AID gets added to the candidate list. So once the candidate list is built, we can now present this to Bob, right? The problem though is that if we presented the candidate list on a card holder to Bob, this is what he's going to see. Okay. Now, this will make no sense to the average person if this was presented on the terminal screen. I mean, for all of you who've been through this EMV course, you guys are not average people. You guys are EMV superheroes. So you guys understand this. But for the average layman, this a string of letters and numbers is absolutely meaningless. Okay, so we've got to present it to Bob and to the other mere mortals in a way that's going to make sense to them, right? So remember, we spoke about this in the EMV issuing section, and I did allude to it in the previous slide, where I showed that where the card responded back with data around an AID, it also came back with with things like an application label, it come back with application preferred name, etc. So that's very important, right? So what the terminal will do is it will look for the associated application label or application preferred name, which is personalized on the card. Now remember, we spoke about this in the EMV issuing section, right? Application preferred name, if present, is the one that will be selected. If it's not present, the terminal will default to application label. Okay, and so when you personalize the card, remember, application label is mandatory, application preferred name is optional. Okay, so when the card responded with the AID that it did support, based on the interaction with the terminal, it also returned the application label. So in this case, for 41010, it's MasterCard, and for 43060, it's Maestro, right? And if the card was personalized with the application preferred name, then it would return it as well. So, in this case, the first one is MasterCard Gold Credit, and the second one is Maestro Green Debit. So I've just made up some names there. Okay. So as I said, so if the application preferred name is not personalized, the optional tag is not on the card, then it will default to the mandatory tag, which is application label. Right? This one here. The order in which these cards are presented to Bob, the order, so the fact that the credit card is first and the debit card is second, is determined by the priority indicator, right? Tag 87, which we've spoken about in previous EMV issuing videos, and I sort of pointed out, when I went through the actual logs of the conversation between the card and the terminal. So what we did end up with is this candidate list that's built by the terminal, then gets associated, to the either the application preferred name or the application label, and then based on the priority indicators set on the card, it would then display it on the POS screen. Now, this is my mock-up of a POS screen. So here's the POS device. A very fancy machine issued by a company called BerryPay. Here's the screen of the POS device. Here's some keys. I just put 3 keys and the keys go down. But basically what Bob would see now is he'd say, please select the card, and he'd see MasterCard Gold Credit or Maestro Green Debit, right? So instead of seeing A804 1010 or A80's 43060, which makes no sense to him, this makes sense to him. So Bob knows, for this transaction, do I want to use my credit card, my virtual credit card, or do I want to use my virtual debit card? He can make an informed decision now, right? Okay, and obviously based on what I want, let's assume that he wants to use his credit card. He'd press the 1 button, or if the touch screen, touch the line, and that would result in the terminal selecting this application. So going forward, this is the application that will now be used during this EMV transaction. Okay, so please note the following. Okay, if no AID matches are made, so if the 3 AIDs that are on the card are not supported by the terminal, they don't appear on the terminal's AID list, that the terminal cannot build a candidate list. Okay, and in this case, you cannot do an EMV transaction. Okay, so in this case, you'd have to do a magstripe transaction. No chip transaction is possible here. In the case of a single app card, one physical plastic, one virtual card, the terminal may or may not offer a selection of one candidate to the cardholder. Okay, or allow the terminal to select a candidate by default. So what we're saying is, in some terminals, you'll notice that even though there's only one virtual card that can be used for a transaction, the terminal will create a candidate list of one entry and expect the user to select the one. Other terminals, if there's only one entry on the candidate list, it won't offer an option. It will automatically default to the only available option on the candidate list, right? So it's one less processing step during the EMV transaction. Better UX there. Okay, and what determines now whether the terminal offers an option of one or auto selects by default could be either the terminal itself. So some terminals have the ability to auto select, and some don't, right? And the card as well. So some cards may be personalized to allow for auto selection of an application, depending on which application version and type you're talking about. Where the card is a single application card, and some don't, right? So between the two, if they both allow, obviously for auto selection, then the candidate list, in the event that there was only one mutually supported AID available, it wouldn't even appear to the user for selection. The terminal would just select it automatically, and the transaction would proceed onto the next step. Okay. All right. So where we are now is, we've sort of done the technology selection. We know it's going to be a chip transaction, and we know it's going to be, the a we know the technology is that we are going to insert a chip card into the POS device, and we are going to conduct an EMV transaction. We then went to the next step where we said, okay, let's have a look at all the available applications or all the available virtual cards that we can use for this transaction, and let's choose one. And so in our case, we did that. So, and Bob chose, let's say, he chose the credit application. And so where this brings us to is the end of this video, right? So we finished step 2 of the EMV transaction. So I'm going to end the video here. In my next video, we are going to touch on step 3 of the EMV transaction, which the part where the current terminals are exchanging information. So, and that's known as, initiate application processing or read application data, depending on which manual you read. Okay. So yeah, the transaction is looking good. It's picking up pace, and yeah, thank you for joining me, and I look forward to catching you guys in the next video soon. Cheers and bye bye.